Yeah, hi. Today's topic is about, as usual, family of quadrilaters. Under that, quadrilater, trapezium, parallelogram, rectangle we have done. So today's one is square, and rhombus. Okay, both at a time I'll explain. Okay, so what is this? Now listen to me very carefully. See, by comparing we can learn the properties of square and rhombus together. Okay, now what are those? Let's check. Basic thing about a square is all sides are equal in a square. A, B, C, D. This is square. Okay, all sides are equal in length, and I told you already. Okay, this is quadrilateral, trapezium, parallelogram, from parallelogram rectangle, and a rhombus. From these two a square comes. So as it is coming from quadrilateral, whatever properties of quadrilateral is having, the same thing trapezium have. All the properties of trapezium are followed by parallelogram. Similarly, all the properties of parallelogram are followed by rectangle and also rhombus. Okay, now whatever properties are there here in rectangle and rhombus, those are followed by square. So whatever properties are there in a parallelogram, let's check with the gram. Opposite sides are parallel and they are equal. Yes, they are parallel and they are equal. Okay, in a parallelogram, diagonals bisects. Okay, diagonals bisects. But extra point is nothing but I'll talk about this later. Okay, let me check. I want to explain in detail about diagonals, so that is why I'm not explaining now. Last few minutes afterwards I'll explain about diagonals. Okay, so parallelogram in opposite sides are parallel and they are equal. Okay, now coming to angles. In a parallelogram, opposite angles are equal, right? So if you observe in a square, all angles are 90 degrees. Okay, 90, 90, 90, 90. When all angles are 90, obviously opposite angles are also equal, right? So, okay, now the extra point what this square is going to have is, now in this parallelogram diagonals are not equal, whereas in square diagonals are equal. So the first property is angle A plus angle B plus angle C plus angle D is equals to 360, and angle A is equals to angle B is equals to angle C is equals to angle D is equals to 90 degrees. All angles are equal. Now second one is length of AB is equals to all sides are equal. AB is equals to BC is equals to CD is equals to DA, and AB is parallel to DC, and AD is parallel to BC. Okay, as usual all these properties are followed by all these three. Okay, even in rectangle also. Okay, now what is the extra point this rectangle this square is going to have means, here only the opposite sides are parallel in rectangle. Here all sides are only opposite sides are parallel and they are equal, and here opposite side, not only opposite sides, all sides are equal in a square. Okay, the next I want to discuss about the diagonals here. What are diagonals here? So if you observe, when I was explaining about a parallelogram, okay, when I do like this, like that, I don't have that proper what we call that material right now. So this diagonal is shorter than the other one, right? So diagonals are not equal in parallelogram, whereas they are equal in rectangle. Similarly, in square, because all angles are 90 degrees, because of this reason diagonals are equal. Diagonals are equal in square. Okay, and they bisect each other perpendicularly. Okay, What do you mean by perpendicularly? Okay, the bisecting is nothing but fine, intersecting at their midpoints. For example, 5 centimeters, 5 centimeters, 2 centimeters, 2 centimeters. Intersecting at midpoint is nothing but bisecting. What do you mean by perpendicularly? See, 90 degrees. If they intersect, if the bisect, perpendicular is nothing but when they are intersecting, each and every angle is going to have 90 degrees. Intersecting at their midpoints, and also at 90 degrees is nothing but bisecting each other perpendicularly. Okay, the meaning of this one is this. So if you see, so the diagonals of a square are equal and they bisects perpendicularly. Okay, at 90 degrees they will bisect, whereas in parallelogram they bisect differently. They bisect but not perpendicularly. In different angle they bisect, like 120 degrees, 30 degrees, like that. If they bisect perpendicularly, it's nothing but they intersect at 90 degrees. The meaning of perpendicular is nothing but 90 degrees. You have learned what is perpendicular and parallel. Perpendicular is nothing but intersecting at 90 degrees. Bisecting is nothing but intersecting at their midpoints. It's nothing but if 10 centimeters length, they are going to intersect at 5 centimeters, exactly at their midpoint they are going to intersect. For example, if it is 4 and if it is 10, they are going to divide or else intersect at O. They are going to intersect at O point, and this O point divides this one side into 5 centimeters and 5 centimeters, and the other one into 2 centimeters and 2 centimeters. This is the meaning of bisecting. Clear? And what does it mean perpendicularly? They intersect at their midpoint and also perpendicular. It's nothing but at 90 degrees angle. I hope you have understood. Okay, you just watch this 2-3 times, you will understand. Now this is about a square. Okay, now what about rhombus? Now I just made it right now. Okay, I don't know whether I'm perfect or not. So these are matchsticks actually. Okay, so now this is square. Okay, in a square all angles are 90 degrees. So 90, 90, 90, 90. Now when I'm doing like this, do you feel it is a square? No. Now then what it is? It is a square. Now what is this? It's a rhombus. In a square all sides are equal. The length of all the sides are equal. Without changing the length, I am doing something here. So what is that? I am changing the angles. As you know, I have explained. Doing like this is nothing but I am changing angle. When I am trying to change one angle, automatically all angles are changing. Okay. So now this is rhombus. I'll talk about rhombus right now. Okay. Now in a rhombus all sides are equal. Diagonals are not equal. See, this diagonal is shorter than the other one, whereas in square diagonals are equal. Why? Because all angles are 90 degrees, so the length of two diagonals are also equal and they bisect perpendicular. Whereas in rhombus, let me talk about a rhombus here. Okay, all sides are equal here, A, B, C, D. Okay, all sides are equal. Now if you take the diagonals, this one is shorter than the other one. The difference between rhombus and square is diagonals. In square, diagonals are equal. In rhombus, diagonals are not equal. This is the main difference. And this difference makes a square from a rhombus, rhombus from a square. Okay. Now here also all sides are equal in a rhombus and diagonals bisects here also. Like for example, if it is BD is 10 centimeters. Okay. Now if they are intersecting at O, both diagonals are intersecting at O. So what is OB? DB is 10 centimeters, then OB is 5 centimeter, and OD is 5 centimeters. And this one is, for example, this one is 16 centimeters. AC is 16 centimeters if he gives. Now what is OA? What is OA? Because you know the properties of rhombus. What are the properties of rhombus? Diagonals bisects perpendicularly. Bisecting perpendicularly. So bisecting is nothing but meeting at their midpoints. Because AC is 16 centimeters, this will be 8 and the other one will be 8. So OA is 8 centimeter and OC is 8 centimeters. This is the main difference of between a square and a rhombus. Okay. Here also in rhombus, opposite angles are equal. Angle A is equals to angle C and angle B is equals to angle D. Next, diagonals are not equal and they bisect perpendicularly. Whatever properties of a quadrilateral are there, parallelogram are there, all those are followed by even rhombus also. The extra one is this. Diagonals are not equal and they bisect perpendicularly. Okay, clear? So we have completed introduction to quadrilaters, family of quadrilaters. From the next video onwards, let's start constructing quadrilates. Clear? If you have any doubts, you can just let me know. Okay, thank you.